Welcome to qnawire.
Hi, so over here we're asked to sketch an energy diagram for the following transformation going from A to B to C, and we're given some information that C is going to be the most stable, B the least stable, and three of the three species, and the transition state going from A to B is more stable than the one going from B to C. In this case, a typo from B to C. So what we're going to have is that our reaction diagram, the reaction coordinate over here and having the energy on this position, what is going to happen is, first of all, C is going to be the most stable of all of the compounds. Let's put it over here on a lower energy. We're told that B is going to be the most unstable. So let's put it over here. It would be B. And finally, A is going to be somewhere in between. We're told that the transition state going from A to B is more stable than the one going from B to C. So we're going to have a lower activation energy in this case compared to the one below from B to C. Let's call this transition state AB, and let's call this transition state from B to C. With this, we're going to have the reaction diagram connecting all of these points as follows. Now, with this information, we're going to answer the following questions. How many intermediates are there? We're going to have only one intermediate, which is going to be B. How many transition states we're going to have? We're going to have two. Which step has the greater rate constant in the forward direction? In this case, the one with the greater rate constant is going to be the one with the lowest activation energy. In this case, it is impossible to provide an accurate answer without having the actual number of the transition states, because even though transition state B and C is going to be less stable than the transition state going from A to B, there's some possibility that this activation energy may be lower than the one that we have below, and that is all going to depend on the position that we're going to get on B. In this case, just based on the relative stability and assuming that the activation energy from A to B, let's call it activation energy 1, is going to be smaller than the activation energy 2, what we're going to say is that the transformation from A to B is going to be the one with the greater rate constant. Next up, which step has a greater rate constant on the reverse direction? And in this case, it is not going to be ambiguous. We're going to get directly that the step from B to A is going to be the fastest on the reverse direction. Now, of the fourth step, which has the greater rate constant, as you can see from our diagram, on the reverse right direction, the activation energy from B to A is going to be way smaller compared to the activation energies from A to B or from B to C. So in this case, the one that is going to have the greatest rate constant is going to be the B to A step, and which is going to be the rate determining or limiting step in the forward direction. And in this case, with the diagram that we generated, and with the condition of the activation energies that I state over here, the limiting step would be going from B to C. And with that, it would be all. Thank you very much and have a good one.